All righty, folks. So we got done talking about conic sections. So now the second half of this chapter deals with matrices. Now, matrices are built on the idea of systems, linear systems. And you guys did a lot of that back in Integrated 1, Algebra 1, where you solved two equations, two variables, like 2x plus y equals 4, x minus 2y equals 9, something like that. I don't care. But it's basically some sort of system. Now, we're not going to talk about the two equation, two variable system. So again, be like, this is what you guys did back in Integrated 1, Algebra 1, where you guys solved these kind of systems like this. And you had to go through and figure out where the point of intersection is of these lines. And I mean, if you wanted to, you could go through and do it. It would be what? The solution would be 2, 3. We're not going to go through and deal with 2 by 2s. We're going to be dealing with, what if we had a 3 by 3 equation? In other words, what if it wasn't just some x and y system like we were dealing with back in our freshman year or 8th grade year? What if it was a three-dimensional system? In other words, we had an x-axis, a y-axis, but then we added height or depth to it to create a z-axis, where we have these lines passing through three-dimensional space. Well, that's what we're looking at today. How do we solve for one of these things? So we're going to, it's called Gaussian elimination, but it's really just elimination. And what it is whenever we start off with one of these, we're always going to start off labeling the equations A, B, and C. Now, you don't have to do this. I really recommend you do it, just because as you're going through, it's easy to get lost in the work behind all these things. Now, we are going to add, we can interchange two equations if we wanted to. We can multiply one of the equations by some number, and then we can add two equations and replace. And we'll talk more about that in previous days. But really what that means for us here is I can take any two equations, just like we did in Algebra 1, and add them together to get rid of a variable. It doesn't matter what variable you get rid of, but I'm going to take any two equations I want, and I'm going to try to get rid of a variable. So for instance, if I were to take the A equation and the B equation, so x minus 2y plus 3z, if I were to add these together, notice what happens. The x's, they're going to go away. So if I were to add these two equations together, my x values would go away. And if they don't go away straight up, that's fine. I can always multiply one or both my equations by a number to make them have opposites. For instance, do you see the opposites here? We're looking to try to always create some inverse term, opposites, so that way when I add them up, I can eliminate a variable. So I'm going to have negative 2x or 2y plus 3y, and that would leave me with just 1y. 3z and z, when I combine those two, I get 4z. And this equals 9 minus 2, or 9 plus a negative 2 is 7. Now, we created a new equation, so we are going to call that equation D. I already have A, B, and C. So now I'm going to take my C equation. Notice that one still has an x in it. So I need to combine it with either A or B, one of those two equations, to somehow make the x go away in this one. And it doesn't matter which ones we use. We can combine it with A, we can combine the A equation, we combine it with the B equation. I'm going to choose to combine it with B, but now if you notice here, I have a negative 1 in front of my B. So I have to multiply that negative 1 by 2 to make it be an opposite. And this is one of the reasons why I like to encourage my students to kind of put like their little operations out in front. So that way, if you make a mistake, and friends, I hate to say it, you're going to make a mistake at some time. Gives you an easier way to kind of go back and figure out where that mistake is. If you can't find it, I'll be honest, the best thing sometimes to do is just start over. But we record those mistakes a little bit to try to see if we can't clean it up. So I'm going to multiply every single variable in that B equation by 2. So now I've created the opposite with my C value. So when I combine them, I would end up with y plus 7z equals 13. I create a new equation. Now, again, I didn't have to do the B equation. I could have done the A equation. I could have combined my C equation with A. So I could have done my C equation with A. So let me write that C1 out here in case maybe that's something you chose to do. So if I were to combine my A equation with my C, what number would I have had to multiply my A equation by? Why don't you pause? Why don't you try to answer the question real quickly? What would you multiply by? Right, since I have a 1 in front of it, I would have had to multiply it by a -2. So -2 times 1 would have given me my -2x. And if I would have done that, it still would have worked. So -2x plus 4y minus 6z equals -18. -2x plus 4y minus 6z equals a -18. And notice, it would have given me a different equation, but still one that I could have used if I really wanted to figure it out. And actually, it's probably better numbers. But since that's not what I dealt with, I'm not going to use it. So now I'm looking at my D equation and I'm looking at my Z equation here. That should have been a 7, not a 7. 7Z, there we go. So we're looking at our two equations and we're trying to ask ourselves, is there something now we can get rid of to get out of these two? Notice I'm down to a system of 2 equations and 2 variables. I got my D equation and I got my E equation. So now we're back to what we did back in Algebra 1, back in Integrated 1. I have 2 equations. I got 2 equations. That should have been a Z right there. And I can combine these two to solve whatever I want to get rid of. Now, for me personally, I'm going to multiply that top equation by a -1. So I'm going to multiply -1 times D. And I'm going to combine that with E to be able to get rid of my Y values. So -1y minus 4z. I keep putting that, I'm not able to read my own handwriting, man. I tell you what. I wrote the same thing here. Some of you guys are going, Williams, you're killing me. I know, I'm killing myself. 7z equals 13. And then, again, this is why we label all of our equations. So it's easy for us to come back and read. If we make a mistake, it's easy for us to come back and chart where those mistakes happen so we can figure it out. So I'm going to combine these two now. I end up with 3z equals 6, which means z equals 2. So now that I found z, I'm going to go back into either equation D or E to figure out what y is. And it doesn't matter which one I go to. I can go to any one I want. But I'm going to pick one. I'll just pick y here. So y plus 4z equals 7. And we're going to plug in our number here. So y plus 4 times equals 7. So this is where they said you eliminate all the way down to one variable. That's the whole Gaussian idea. Get it down to one variable. Solve that, and then work your way back up, going backwards to find out the other two. So y equals -1. Now so we have that -1. Now we're going to go back into one of our original equations and figure out what x is. So I'm going to go back to the A equation. X minus 2y plus 3z equals 9. So I'll go back to that original equation there. You go back to, so what I was able to do here is I was able to go back to any one of those original three to figure out what my other values were. So 2y plus 3z. I already know what y and z are now. So we're going to go figure out what x is. So y was -1. Z was 2. So I have x plus 2 plus 6 equals 9. X plus 8 equals 9. That means x equals 1. Now go ahead and pause the video here and plug this point. Notice how we don't write it as x and y anymore. We write this one as x, y, and z. So always write your solution as x, y, and z. Because we have 3 axes now, not 2. Once you go ahead and plug that x, y, and z back into your 3 original equations, make sure that those are the actual values. So to show yourself that they actually do work. All right, so this is kind of what we're dealing with here today. We're going to be basically taking a system of 3 equations and we're going to solve it to get rid of one of our variables. So notice I left this up there for a second. What I'd like for you guys to do is go and pause the video and see, kind of following the way we had it before, see if you guys can actually go ahead and see how you do on one of these by yourself. Go for it. All right, friends, let's take a look here. So I'm going to call this one A. I'll call that B. And I call that C. Well, I'm looking at that A value, 4, and I see that C has a -1 in front of it. So if I were to take the A and combine that with 4 times C, I bet I could get rid of my x's again. And again, I don't have to get rid of my x's. I can get rid of any variable I want to. It doesn't have to be x. I just think it's a little easier on this one to get rid of the x. Biggest thing you got to remember is be very, very patient and very organized in your work. Again, that's one of the reasons why I put the red subscripts in front of it. It just helps me keep in line when I make a mistake. Like you saw in the last problem there, I just dropped a couple things here and there. It happens. Don't worry about it. Don't beat yourself up if it does. Just take your time. All right. So minus 20z. Well, these are going to be big numbers, aren't they? 17 times 4, oh, that 34, that's 68. All right, so we're going to combine these numbers right here. And when I combine them, I end up with 5y minus 19z. Ooh, that's a big number. Equals 58. I'll be honest, when I did this one earlier today on my own to get ready, I combined equation A and B to begin with, which is fine. You can do anything you want to. It's really on you. This time though, I thought, let's combine everything with C. There's so many different ways to combine these, because you can combine them in any way you want to get rid of any variable you want. It's really whatever makes the most sense to you. So 3z equals 0. There's my b equation. This time I'm going to multiply 2 by my c equation to get negative 2x. So you can see how my x's are opposites again. Plus 4y minus 20z equals 17. Like that. All right. So that means, oh, I forgot to multiply the 17 by 2, didn't I? Let's try that now. That's been negative 10 there. So negative 2x plus 4y minus 10z equals 34. So got to be very careful with our numbers here to make sure everything works out right. So 5y minus 7z equals 34. I'll call that E. So I have my D equation, I have my E equation. So when I combine those, I think I can make my my Y value go away pretty quickly. So let's take my D value, my D equation, and I'm going to multiply my E by negative 1. So 5y minus 19z equals 58. And then negative 5y minus or plus 7z equals a negative 34. When I add them up, I get negative 12z equals 24. So when I divide by negative 12, I get z equals a negative 2. Now, we're going to go back to either our D or our E. Doesn't matter which one. We're going to go back now and we're going to find out what y is. 5y minus 7. I'll go ahead and use this one right here, negative 2 equals 34. So 5y, not really sure what happened there. So 5y minus 7 times the negative 2 equals 34. That was supposed to just be z right there. So 5y plus 14 equals 34. So 5y equals 20. Y is 4. Now plug it back into any one you want and go figure out what your x value is. I'm going to plug it into B. It doesn't matter which one you plug it into. Your call. So here we go, 2x plus y, and we're going to make that 4, plus z equals 0. So 2x minus 2 equals 0. 2x equals 2. X equals 1. So now I know your notes doesn't have another one of these right off the bat to try, but we're going to move ahead a little bit. I'm going to have you guys do another one just to really make sure you get it. So you're going to write this problem on your notes in general. We're going to go right here to this little equation that I've given you right there. So even though it's in another thing in notes, we're going to come back to it. So you're just going to write this one separately, and I'd like you to try it again. So go ahead and pause the video, solve this one using system of equations. All right, let's see how you did here. A, B, and C. So to begin with, I think I would have taken A and B and put those together. Oopsies, we've already done this one. Let's go to a different one, huh? Let's try this one. This one looks fun. All right, pause the video, try that one. My bad. All right, let's see how you did here. Here we go. I see an A, B, and C. All right, if it were me personally, I would take A and multiply it by 2 and combine it with B. So I'm guessing you guys probably did something similar to that. So 2x minus 4y plus 6z equals 14. And if I combine it with the b, 2x plus y, now here's what I want you guys to look at here. Did that work? It didn't work, did it? So instead, I probably should have multiplied it by a -2, right? So always realize if things don't work out, no harm, no foul, just clean it up. As long as we're organized about our work, we'll be okay. So now we have 5y. There we go. That's going to clean up just nicely then. Minus 5z equals -10. So we'll call that D. Now I got to take C and combine it with something. So what did you guys combine C with? Yeah, I probably would have used A as well. All righty, so let's take that and multiply A by 3. So 3x minus 6y plus 9z equals 21. So we have -4y plus 7z equals 11. So we'll call that E. All right. Now we're going to figure out what can we multiply by E and D to make this work. What if I multiply D by 4 and E by 5? Honestly, one of the things we could have done is we could have divided that whole D equation by 5 and get it lower before we did all this, but that's okay. So 20y minus 20z equals a -40. -20y plus 35z equals 55. Add them up. 15z equals 15. So z is 1. So you got your z value. Now plug it back into either D or E, doesn't matter, and figure out your y value. I'll plug it back into my D. So 5y minus 5 times whoop equals negative 10. So z was 1. There we are. So 5y minus 5 equals a negative 10. 5y equals negative 5. And y equals negative 1. And then plug it back in to figure out what x is. I'll use that A equation. All right, so x minus 2 times whoop plus 3 times whoop equals 7. So we're plugging negative 1 in for y, and we plug 1 in for z. X plus 2 plus 3, that's a positive 5, equals 7. So x equals 2. So 2, negative 1, and 1. All right, so we go ahead and we solve that there, plug it back in, double check your work, make sure we were good. All right, so I wanted you guys to have a little extra practice at this. We had 2 on our notes. Usually 3 makes us really, really good. Now let's head back up to our notes here. Sometimes, friends, we get special cases. So what we've been looking at is problems where we get an x, y, and a z. All of these have had an x, y, and a z answer. But sometimes we do get a problem where when we get all the way down, all the variables cancel out. And we get 0 equals 0. When that happens, we say that it has infinitely many solutions. Other times, we end up getting some number. We get 0 equals some other number. It's just not 0. All the variables go away, and we get 0 equals some number that's not 0. And when that happens, we say, okay, well, it turns out in that one, there is no solution. So sometimes we have infinite many, sometimes we have none. So we're going to kind of expect to see that happen here on one of these here. So why don't you guys go through and see if you can actually solve this all the way down and figure out which one we're going to get. Go and pause the video and give it a shot. All right, let's see how you did. First of all, I'm going to take A and C because I think those x's are just asking to be eliminated. So I got x plus y minus 3z equals negative 1. I get negative x plus 2y equals 1. Now notice I don't have a z there. That's okay. I just need to add essentially a placeholder in there. So I'm going to add essentially a plus 0z. There is no term there. That's okay. We don't have to have one everywhere. It's nice, but you don't have to have one. So 3y minus 3z equals 0. Okay, so we'll call that D. So the other equation we had there was B, and that was y minus 0, or y minus z. That would have been bad. Y minus z. Now notice, it doesn't have any x's. So I don't even have to worry about it. I can go right to combining B and D. So if I'm looking at that, what if I were to combine B with negative 3? And then combine that with D. what would happen? And I can do that because, again, B didn't have any x's in it to begin with. So negative 3y plus 3z equals 0. 3y minus 3z equals 0. When we do that, we end up with 0 equals 0. In other words, it doesn't work. I mean, it does work. There's an infinite number of solutions. Now, there is a way you can go through and write a solution for it. I mean, because if you really wanted to, you don't have to, friends. If you really wanted to, you could actually go through and come up with a solution where you say, all right, well, that means that whenever we're solving these, y would always be equal to z. And you put everything in terms of one variable if you wanted to. If you were to take this all the way out, you don't have to. You would end up creating this idea that x would be equal to some other variable as well in terms of z. And so you could then go ahead and write everything in terms of y if you wanted to. Y, this would be y. And then if you plug x up here, we're not going to ask you guys to do that, okay? And you'd end up with x is equal to negative 1 plus 2y. Again, we're not going to ask you to put everything in terms of one variable. You'll see some places where they'll do that. All we're going to ask that you guys do is when you see 0 equals 0, just go ahead and put infinitely many solutions. You don't have to tell us how they all relate to each other. You can, but you don't have to. Okay. If it's no solution, well, you just don't even worry about it. You just type in no solution. So you don't have to put all your terms in terms of one variable to tell us the solution set. I'm going to do that. All right, well, friends, it wouldn't be good if I didn't at least give you a word problem. So luckily I wrote one for you guys to share with y'all. So how about I go ahead and share it with you guys? All righty. Go ahead and read it. And here's what I want you to do. First of all, determine what your three variables would be. So go ahead and determine what your three variables will be. So what are the three things we're dealing with here? Let's see what we came up with. Three things. We have orchestra seats, we got main seats, and we got balcony seats. Now, before we ever do a word problem here, we always got to make sure we write our let statement so we know exactly what we're doing. So let's let x equal the number of orchestra seats. Let y equal the number of main seats. And let's let z be equal to the number of balcony seats. So these aren't in your notes. You're just going to kind of add this into it. So I want you to kind of get an idea of what it looks like before we get there and before you do this on your homework. All right, now using these variables and this idea, see if you guys can come up with three different equations. Go and pause the video and see what you come up with. After you have those three, unpause it. All right, let's see the three equations you came up with. First one I saw is it has 500 seats. That means if I add up all the number of seats, I believe it should be 500. So x plus y plus z is going to be equal to 500. The second one, let's see what you guys came up with this one here. It says if all the seats are sold, the gross revenue is 100. And by the way, remember, revenue means money, so we're dealing with money here. So if we multiply every seat by how much they cost, I should be able to get a second equation. So $50 per orchestra seat, so 50x, plus 35Y, $35 for a main seat, and $25 for a balcony seat. And if I were to add them all up and sell out everything, so we are essentially, it's Hamilton after Hamilton after Hamilton, we'd have 17,100. How about your last one? Were you able to come up with one of those? So all main and balcony seats, but only half the orchestra seats. That gross revenue would be 14,600. So let's see here. In this one, we'd have half of the balconies of the orchestra seats. We didn't sell them all. Only sold half of them. But we did sell on the rest of them. So if I clean that up just a little bit there, half of 50, that'd make that 25x. So 25x plus 35y plus 25z equals 14,600. So we got a little bit bigger numbers we're dealing with here. No harm, no foul. Friends, we'll call this A. We'll call this B. We're going to call this one C down here. Why don't you guys go ahead and pause the video and see if you can figure out how many of each type of seat there was. Let's see how you guys did. First up, I'm going to multiply my A equation by negative 50. So negative 50 times A. And I will combine that with B. So negative 50x minus 50y minus 50z equals negative 25,000. And I have 50x plus 35y plus 25z equals 17,100. Add straight across, I get negative 15y minus 25z equals negative 7,900. So we'll call that D. And if it were me, I probably would have also combined A with C. So negative 25A. Combine that with C. All righty. So negative 25x minus 25y minus 25z equals a negative 12,500. $25x. Oh, this is going to be kind of interesting here. You guys probably hopefully saw the same thing. The z's are going to cancel out. And the x's. I'm going to be left with 1. This just made this problem be a whole lot easier. And I have 10y equals 210. Well, friends, turns out that's my E equation. I'm loving E because E I can just solve by itself. Y is 21. 210, sorry. That means I have 210 main seats. So now plug it back into D over here. You just go straight into it. Let's see if we can figure this one out. So we're going to put our 210 in for y. And we go ahead and solve it. So negative 3150 minus 25z equals negative 7,900. Add 3150 to both sides, you get negative 25z. There you go. That's kind of a z, isn't it? I can do better. Is negative 4750. Divide both sides by z and you get 190. And then figure out how many of the other ones you had. So x plus y plus z is 500. So we had, what was that, 210? And then we had 190z. So x plus 400 equals 500. That means we had 100 orchestra seats. All right, plug your numbers back in there if you want to check to see if it works. But being that this is a word problem, we have to make sure we know exactly, or we write it essentially out as a statement for everybody to know. The Broadway Theater had 100 orchestra seats, 210 main seats, and 190 balcony seats. And we're done. All right, friends, that's going to go ahead and be a day for today. I will see you tomorrow, and we will talk more about systems and matrices.